2 seconds. All right, folks, let's get started. Let me move the screen to the right to the first post. We have 37 posts um, on this Figure Friday. Michael, just so you know, I don't know if you've seen all the Figure Fridays since last year, but this was impressive. It's exploded with 27 posts. We usually don't get so many posts. Well, I think
Great.
we added 20, 25. So people, and beyond the number, in addition to the number of posts, you can read by the content of what people said that this very much interested our community. We usually do um, a bunch of different data sets, and it includes Dash, but this was a fairly unique topic, very much about something that we haven't really done before. We did one kind of oil, I think, data set, um, but with the unique also opportunity to build 3D graphs, and the community really appreciated it. So, Michael, thank you for bringing this up. Thank you for agreeing to do the Figure Friday. And then Michael's also going to join us for our Plotly Hangout for the month of July. I think it's July 30th. So, Michael, before I scroll down and review some of these graphs, can you give us? I put the sample figure here. Just a brief intro for those who are listening to us and are for the first time hearing about this data set. What can you tell us about it?
Sure. Yeah. So, the main goal of our work is to make, new maps of groundwater salinity underground. So there's a lot of interest in trying to understand, how far down we can go underground and still have, kind of usable water, or a low enough salinity that we would care to monitor it and protect it and potentially use it. And so we've been working on methods to try and do this, and we finally have had some success with that. And so we kind of end up with these high dimensional models, but then if they're locked away in a paper somewhere that only has a couple of views of it and it's hard to understand, it's not that useful. And so that's why we started doing these Plotly figures. Is our cooperators, the water regulators in California, who really use these models, they've been really appreciating these visuals because it allows them to access these underground models and take a look at what's going on, rather than just getting one or two views in a paper. And so yeah, they have like I said, we've gotten a lot of positive response on these models, and just the fact that they're interactive and shareable with an HTML file is a big key for us, because there are other 3D softwares out there, right, that do visualizations, but a lot of them are behind a paywall or need special software or something like that.
Really nice. So when did you start using Plotly in general for these kind of for your work?
Probably something like 2018, 2017, something like that. Yeah.
Very nice. Cool. All right. So, hey, Alex. Welcome. Thank you for joining us.
Hello. Hello, everyone.
Hello. Alex said, I actually just clicked on yours. So I just opened it. See parameter for statistics. So this is the one that Alex created. This is actually pretty comprehensive because it's a Dash app that includes Plotly figures. In this case, a 3D graph. This is a scatter plot, I think. Alex, do you want to introduce your app to our community, to our listeners?
Yeah, my pleasure. Of course. Well, basically here, what I try to do after all beauty graph that Mike and all the community made, a part of complement graph. In this case, basically what I was looking for is exactly granularity that is not in Are you hearing?
Yes,
Are you
we can hear
listening?
you. Yep.
Okay, okay. In this case, and also try to understand better all the parameters that this all interesting data that Michael uh, gave us. Well, basically here what I did is the first one that you are highlighting there, Adam, is a heat map. It's a heat map. I try that you select the total dissolved
Okay.
solid,
Yeah.
exactly the total dissolved solid, and there are some, okay, and basically what I like to see here is what exactly how was amount of solid around the this sample have, no? Basically the salinity milligram per liter. Also, to complement, the second graph you see is also here you can see the points that are the points, basically it's a scatter plot that shows the specific points, data points that are dispersed in all the data. Ne? Well, then the exactly, if you look at here, for instance, exactly, you will see the second one also. If you select the total dissolved solid there, you can see here the longitude and the latitude. It's like if you have in horizontal view to see the latitude and vertical view to see, it's like a slide of cake, let's say it in that way, to see exactly how is this the distribution of the salinity at all the point in this chart, in this data sample. So the my main idea was exactly granularity. It look for a deeper understanding about the data. Basically, of
Thank
course, ask me. Go ahead,
No,
Ad.
thank you. Thank you, Alice. I also wanted to point this out. You meant you every graph um, dissects or visualizes the data based on the parameter that you allow users to look at, the dissolved solids, and you added these parameters here, right? Temperature, electric resistancy.
Exactly. In fact, this is one of the improvement I will do to the 3D graphic in the hover. For instance, if you select a point, the idea of in the hover, the other graph that Mike and the other people made, to see exactly what the temperature of that point, what the bicarbonate, what the other parameter I don't remember, the resistivity and all. Then in that point specifically, in for instance for 3D graph, that's the reason why I can see this here. I'm gonna do something to go deeper in order to understand exactly
Yeah,
how look like the data.
yeah.
And that's
Thank,
basically okay.
thank you,
Here,
Alex.
no, imagine my pleasure. Here you can see exactly the cut position, the latitude and the longitude, and also if you select one, you can compare with the graph, uh, with the above graph, and it gives you more insight,
Yeah, yeah.
basically about the data.
Very good.
That's also
Um, Michael, what do you Stevens? What do you think of this happening? That like what? There's a lot of things that Alex points out here that it allows a user like you or somebody in the field to visualize and to explore. Was there anything specifically that drew your attention? Anything that you thought, okay, this would actually be very helpful for people in my field?
Yeah, I think that, it's
Michael, I can't really hear
oh,
you.
sorry.
Your
Is this better?
microphone is like very low volume, like we lost you.
How about now?
Yeah, perfect. There we
Okay. Yeah, it is very useful. I like this one a lot. It's complicated to show data, that's in really it's in 4 dimensions, right? Well, it's some value that has 3 coordinates, right? And so it's nice to see it in this map view and then also in a depth slice. So that is useful, and be able to go through those, have the slider to go move through the space too. That's great. You beat me to, having the drop down list to look at all the different variables, temperature and bicarbonate. I never got that part done on my visual. I only did it for TDS, and I never had the time to make a drop down for the other ones. And so that's nice to see. There were a few, it's nice to be able to see them all. And, like I said, I only had time for the TDS, so it's cool to see the drop down for all of them.
Nice.
Yeah.
Why is the bicarbonate an important parameter in your field?
Yeah, it's a little bit, it gets a little bit into the weeds, but, in short, we have the kind of the first order way we understand groundwater salinity is through, we have these wells drilled into the ground, and we take water samples from the wells and then send it off to a lab, and they measure the TDS. They measure the salinity. But we only have a limited number of those measurements. And so we kind of fill in the spatial gaps with the resistivity measurements, which are much more plentiful in and around these oil fields, because they are resistivity measurements that the oil companies have taken with the purposes of looking for oil, but we can use it for the purposes of, mapping water. And so kind of at the end of the day, we're building a relationship between the resistivity and the salinity. So kind of how conductive it is going to be related to how salty it is.
Okay.
And bicarbonate it sort of is involved in that relationship, that translation from resistivity to salinity. And so if we know what it is, we get a better prediction. And that just has to do with the electrical properties of bicarbonate versus the electrical properties of sodium chloride, or traditional NaCl, which is the other main thing in the water. So there's 2 dominant things: is the bicarbonate, NaCl, and if we know the split, we get a better prediction of salinity. And so again, a little in the weeds, but it's in that relationship between conductivity and salinity.
Okay, cool. Thank you for explaining that, Michael. I'm glad Alex had the foresight to think ahead and know what parameters and drop downs to put down that you would also be able to do. One thing I wanted to ask the developers here, potentially even you, Anne-Marie, might know the answer to this. We see in Alex's beautiful Dash app with this great component that there are some depths where we don't have data, because I'm assuming we don't have data unless there's a bug. I forget the data set. I'm assuming we don't have data in every single meter. And there were some that I clicked on where the graph was empty. Don't know if it was just a bug. So how would we do it where maybe it was just a bug, those that are empty and show an empty graph will not show an empty graph, and will maybe show the one closest to it? Or maybe it was just a bug. Alex, or Michael, do you know if every single meter has sensors in it, has data?
Well, so, the data set that I provided was the modeled data. And so we took, our raw input data set, comes from these specific locations where there happens to be these wells.
Okay.
And so it's just naturally discrete in space. And we built a very, elaborate interpolation model using Gaussian processes to interpolate all the data. And so what I provided for this challenge was the data I'd already interpolated. And so it's essentially continuous in 3D space, except I just kind of subsampled it down so it wasn't crazy dense and a huge file.
Okay.
But then that SciPy, that piece of SciPy code, where it calls grid data, that is an interpolator as well, but it's sort of an interpolation on the interpolated data. And so, that's what folks were using to make the data I provided to be continuous at whatever location they wanted. Does that make
Yeah,
sense?
that
Alex,
yeah, that does make it clear. My question, I guess, would be, would, from a data visualization best practice point of view, would it make sense to, is it okay to leave it like this, where there's some depths where there's no data, right? There's just no data available, and the user would know that. Oh, okay, I know that in 391 there's no sensors. Or should we show the closest depth visualization available?
Yeah, I mean,
Michael?
oh, go ahead. Sorry.
No, go ahead, and then I can share what our community members say.
Yeah, I mean, that's a great question, and I think it just is going to depend on the situation. So I think we usually refer to uncertainty for this question. So our modeling technique models things kind of as a normal distribution or like as a bell curve. And so all the data we're showing today, like the TDI, all the salinity, that's actually just the mean of the distribution. So at every spot on the graph, every pixel, it's a bell curve.
Okay.
And so we have uncertainty maps associated with every quantity. So we'll have, here's salinity, what we think it is, and then we'll have another whole map, that is like the plus or minus for our prediction. And so we chose to show most of it because we have those uncertainty maps, and the user can say, okay, well, I know they're really uncertain of salinity in this zone because there's not a lot of data. So because we kind of provide almost two maps in every scenario, like, what the value is and then the plus or minus, we decided to show most of the data.
Okay, got it. Thank you, Michael. Anne-Marie did bring up a good suggestion, not only for possible implementation here, but for similar occasions or situations. Dash man-time components has a parameter or a component within the dash man-time slider. This property is called restrict to marks. And if you use restrict to marks, the graph will only select the certain data points along the slider. So it'll only show the data points that are available. Did I get that right, Anne-Marie? Okay, perfect. I got it right. Perfect. So that's Dash Man-Time DMC. If nobody has heard of it, which is hard to believe, but it's a very popular community Dash library. But just go to Dash Man-Time components and make sure that you try and use the latest version. And definitely join the Dash Man-Time component community on Discord. And join our forum if you want to learn more. All right, cool. Alex, thank you so much for building this app and sharing it with us.
Imagine. Thank you. Yeah. Thank you, Mike, for the data.
Oh, yeah. Thank you.
Awesome. Now let's go to another graph we have here. I want to highlight people's graphs and Dash apps that are couldn't take their lunch break and to join us at this particular time. Esther built a nice, I don't think, maybe she put, here's the code below. It's not on PyCafe, but we can run the code. And if we run the code, it will generate these two nice graphs, 3D graphs, elevation. Michael, what does easting and northing mean? What does that mean?
So it's just latitude and longitude that's been projected into meters. It's
okay.
Just because 1 unit of latitude is not equal to 1 unit of longitude, and so we do projections in order to do math on it.
Okay, perfect.
Yeah.
That, and then we have this right here. Okay.
It's just a coordinate transformation. Yeah.
Oh, okay. Got it. And then we have You, Danny, great graphs and data apps. Um, but unfortunately, because of time zones, they're not able to join us. Here, being able to visualize the volume segmented by the proposed ranges. Geospatial visualization of the study area. Okay. And here we have, it's hard to see, salinity also versus the easting and northing and the depths, so similar to what Esther created. All right. Oops, computer got stuck. Can everybody still hear me?
Yep.
Okay, so this just got stuck. Okay, good. I think we have two more. Then we have Alex and what he built. And then we have Thomas's and Mike's. Mike Bertel, who couldn't join us today. So let's go. These are the last two, I think. Yeah, let's go to Thomas's first. So Thomas has provided the code as well. We have it here. I asked him, I actually didn't check, he might have answered already, but I wasn't sure what these, Michael, do you know what these two slices would refer to underneath the markers?
I wasn't sure either.
Okay.
It could be just the rock layers.
Yeah, there's a cross rock layers that, verify interpret the surface, go volume and go scatter 3D. Inject else. So let's see. I asked him the question. We'll see if he can share more about it. Okay. But it really looks nice. And then Mike spent a nice amount of time to he describe all the things that he did here, tweak the height and the background color of 3 planes, and this. So this is an interesting graph right here, Michael. How would you interpret it? Let me take a better look at it. Unfortunately, we can't interact with it here.
Yeah, I think that looks like that's the the land surface, and it's just he has the the Z scaling turned further up, right? So I always turn mine down just to make it not look like it's a big mountain range, because it's actually more subtle in the in reality. That's all the difference, I think.
Oh, okay. Okay.
Yeah, in that sample code, I have just like where you can just scale the axis, with a fraction, and I think I have it set down to like 0.2 or 0.3 or something.
Oh, okay. So this is actually what we're seeing here is like the mountain range above ground, obviously.
Right. It makes it look like that, right? But yeah, these hills are, maybe they're a couple hundred feet this zone, off of sea level.
Yeah.
Or yeah, it's 400. So it's 400 feet. 300 feet of change,
Yeah.
So you wouldn't really notice. That would look like a hill, right?
That would look like Mount Everest. Groundwater scatter 3D we have here. I don't think I can zoom in. Oh, there we go.
Yeah, it looks like a scatter plot, just given every individual point a color for the salinity.
Nice.
Mm-hmm.
Kind of nice to see how I think it's a lot bluer and becomes red as you go down.
Mm-hmm.
All right. So those were all the all the graphs and data asks that were submitted this week. Michael, final remarks, like general thoughts of the Figure Friday week and the graphs that you saw. What would you say?
I think it's great. I mean, I'm so glad that there was interest and that people were excited to play with the 3D data and I think that it was awesome. Without tons of background, that people made such awesome graphs.
Yeah,
I think it's cool. Just it gives me ideas on how to, for the next visual. Trying to get that drop down box in is certainly something I want to do to get all the parameters in there. And then, Yeah,
Well,
and
we didn't really go over that. Like, I know you mentioned here that you might want to add a drop in with some parameters. But anything else you were because look, your graph that you the final graph that you made is pretty impressive. It has a lot of features, comprehensive. We don't at a certain point we don't necessarily need to add more things, but looking into your field and what you want to do with Plotly, were you envisioning other changes or building other types of graphs?
Yeah, would I think I would like to maybe experiment more with Dash because I don't really know Dash. I've never gotten into it, and I've just been doing Plotly, and so seeing what Dash can do is really nice. Having a Galaxy had those summary statistics, and there's more you can do. It looks like, and so that's maybe on the horizon for me is to try and learn more about that.
All right. Well, you have to join and be in our forum of community. Do some Figure Friday sessions. That'll really help you if you have the time to practice and your Dash skills.
Yeah. I know at one point we tried to hire some folks to do this and it didn't pan out, and so it fell on me. But it'd be awesome if because time is a constraint, right?
Yeah.
So you can only spend so much time on because you can get as you guys know you can just spend time on this and to make it better and better, and at some point you got to stop. But
yeah. We're crazy with it. Yeah. All right, folks. Well, thank you everybody for joining us, for the graphs that you created, for sharing with us, and most importantly for supporting each other, right? With different questions and different things to build along the way, different feedback and suggestions. Always very, very helpful. I appreciate everybody joining. I appreciate everybody participating. And I'm going to release the next Figure Friday session data set in a few minutes, probably around in about half an hour. So we can start looking into that, and hopefully we'll get as cool and as interesting graphs as this week's. Thank you, everybody. Have a wonderful week and a good weekend.
Bye. Have a nice weekend, everybody.
Bye-bye.
Okay.
Bye.
Bye.